I'm gonna hit record. Okay. One of the things I've been looking at for a different like manufacturing technique that we can use to possibly make some of our parts lighter and stiffer, but like still able to do what we need, is it's an aircraft technique that was actually, I think it was partially in that one aircraft like repair manual thing. But it basically in any like lightning hole that you put into something, you flange the actual interior hole. And there's a couple ways to do it. One of which is called a Dimple Die. I'm going to share screen. Wait, what did it? Is it sharing the screen? Why is it not putting the thing? Oh, there it goes. Okay. So what they do, there's a lot of different videos. This one, it just makes shows a part that's reasonable and shows the process a little bit. But basically the idea is where you have any sort of like round cutout holes, they don't actually have to be round, they can be other shapes. You flare the hole. Where's the picture that makes sense to what we're trying to look at? Yeah, so you can kind of see it get done there. So you have this Dimple Die press, and it puts those flanges in the metal. So now instead of just being a flat part with holes in it, you add 3D structure to get it much stiffer where any of those flanges are. So one of the cool things, so like the whole thing gets a lot stiffer when you have those flanges. So this was used a lot to make aircraft for a very long time. This was like the way to do it because you can get a thinner overall panel and take weight out because of so yeah, you get a lighter overall panel because you're taking the weight out from the holes, but it becomes as stiff as a heavier panel since you're adding in the stiffness from those flanges. And one of the cool things that we've seen recently
with a 3D printed Dimple Die
is they've started 3D printing the Dimple Dies. So you don't, like, we may have been going into actually buying them or something too, but you can make custom shapes for the process of doing the actual like stiffening and everything.
Mentioning the punch press cuts the corresponding hole in the sheet.
These are also cool. So these are just like knockout punches, which I don't know if he actually shows the process, does he? You basically ratchet and you pull a hole, you punch a straight hole into relatively thin aluminum. It gets a lot harder if you're trying to do stuff up at like 0.09 or something like that. But as we start moving, if we start moving towards lighter aluminum, like 16th wall,
the sheet metal is placed on
you can do a lot more.
Press. The counterpart is put on. Now the entire package is put under pressure.
So you would do it on like either the arbor press or like in this case, it's like a hydraulic press.
The Dimple Dies fit together perfectly and presses the sheet metal into the negative shape. When opening the Dimple Die, you can see the perfectly shaped bead with a rounded edge.
All right, so you can imagine trying to fold this sheet of metal now along like anywhere through that circle is going to be so much harder than it was when it was just flat. So you get to have some of the lightning. You get the benefits of still doing the lightning, but you actually get more stiffness than if you didn't cut the hole. So like this is definitely stiffer than even just the flat plate was without any hole or anything in it. And it doesn't take much since you can do it with 3D printed dies if you need to. And even with the metal dies that you can buy aren't that expensive. Like each die is like 30 or 40 bucks, which is not terrible since you can reuse them forever, especially if we're just doing aluminum. Like those dies are designed to do like steel, and we won't be doing steel probably. So getting some stiffness back in some of our plates is interesting. They also, yeah, so this guy, they try to even do a bead die, which is a lot harder and thicker material. You can show what the end product of that looks like here in a second.
The second half of the tube comes last. If the pressure is now applied to the package, the template slowly pushes together and presses the sheet into the desired shape. This must not be done too quickly or with too much pressure, otherwise the sheet metal may be cut.
Wow, what's happening?
If you separate the tools half now, you
that's
can
not what I
see
wanted
the
to do.
raised circular bead around the pressed bead hole.
I want the annotations to go away. Okay, but yeah, so it actually, they made a raised bead in this one. This is definitely trickier to do in anything really thick. This is some really thin metal. Even in like 16th aluminum, that would be tricky to do with a 3D printed part. And takes up more room and stuff too to figure out. And you actually like it deforms to both sides of the part too. But just doing single side, especially on parts where we don't need one side to be perfectly flat, like especially on potentially our drivetrain where we have like the inside where the wheels are, we don't really mount anything to that inside ever other than where the shaft bolts go and other standoffs, but we can plan for all of those. There's never any other flat plate that gets mounted anywhere. Are there any questions on why that makes sense to do? So there have been some, oh, that's something else. We're gonna say, so the one team, there's a few teams who have done it in the past. Probably the most well-known. Oh, so yeah, Citrus is a well-known team. That is true. So Citrus did it in 18, right, on their ramp?
Yeah.
In 2011, I believe, yeah, so Spartronics in 2011 is one of the teams I remember doing it. All of these holes going down their arm, and then even back here in this upright, you can see they made, I don't know exactly if they made custom ones or what, but they have triangle, circle, square. They did like the first logo. But their whole chassis is dimple dyed that way. And have flanged holes everywhere. So yeah, so there are some people who will do it with the, like the sponsor could do it, but it does seem relatively easy enough to do it ourselves. Because it was their, yes, you can see over here on their ramp. So yeah, so their ramp here is just a big sheet of aluminum with webs, and they just drilled and did dimple die. So I don't know if they did this in-house or if they did this at a sponsor's place, but it's definitely doable to do this in-house relatively easily. This one's a little trickier because you have to, if you're trying to do full sheets like this, I guess if this one sheet is a full individual sheet, it gets harder to do in the middle because you have to have a press that can press in that far. Depending on how thin the metal is, you could also do it with, you can do it with like a hammer if you really wanted to, or like a mallet. As you get thinner metal, that becomes easier. As you get thicker, it becomes much harder. Okay. Yeah, so that is one of the things I've been trying to figure out if it makes sense to ways to make some of our like our drivetrain possibly lighter by being more confident in using 16th wall aluminum compared to using 0.09, which we have been. And there's probably some places where we can get some height and weight out of our drivetrain as well. What was the other thing I was going to do? So let me. So like in our 2020 drivetrain, there's quite a bit of, right, there's a lot of wasted space, right? There's a ton of metal that doesn't need to necessarily be there. We don't use all of it. There's also a lot of height that doesn't do much since we're only critical mounting are like the bolt holes. These ones got a little bit, this year's drivetrain got a little bit bigger since we were putting in, some of that was set by like the gearbox height, because we had to keep this raised up for the forks that ran underneath it. We'll go over more of this on Thursday when we do the full design review for this robot. But just how do we make some of these panels smaller than they currently are? I forgot we did that. I forgot that this panel's shorter than this one. There was reasons for that. But I guess those reasons don't have to exist. Okay, so what was I gonna say? One of the things I was looking at, I was planning to do, and which I figure I can do on stream, is start looking at start playing around designing a rev of a drivetrain that gets thinner metal and looks at what the flanged lightning holes could look like. So we can start seeing what sort of shape that new one would take. Because there's some things we'd already talked about, like potentially not, once we're not covering this, so if we don't have like this inside flange, or we don't have this inside piece mounting to the outside one anymore, partially because of the balls and partially we just don't really mount to this top structure very often. Right, so like this top L bracket mounts there, but most everything else, we mount flat plates to either side of this rail. And since we're not mounting across here as much, a lot of this metal is also basically wasted, right? There's no real reason to have this whole plate here if we're not using it, where we could do something. This is reasonable and fine, but this isn't even the strongest way to support. This was the elevator mount, right? So this went up. There's definitely ways we could make something to support the elevator that is actually stronger than this little bent bracket, because you could tie it into this outside panel if we wanted. There's all sorts of things we could do. So what was I going to look at? So I wanted to start looking at, so I wanted to kind of go through the process of what I do when I'm just like brainstorming a new concept, basically. So we can look at a new, the first part would just be a part, since we're just going to play with kind of the sizing and what it would look like to even make something like that, right? So everything here is just kind of the initial sketch of what a side panel for the robot would look like. I'm going to throw in some random numbers to begin with. Those eventually get changed, but that's kind of the initial sketch. Assuming we stay with our 6-inch pneumatic wheels, they're a little bit larger than 6-inch. What did we eventually figure out? Because they're 6 inches to the floor, but they're a little bit, when you're running, the outside diameter is a little bit smaller, because the compression gives us about 6 inches, but this flat diameter here is going to be bigger than 6 inches, but the distance from the center axle to the floor is going to be less because the robot weight compresses the wheel. So normally, if we know they're all the same size, I'm just going to have one dimension. So I'll select them all and do equal. What was I going to say? Right now, I'm not going to worry about dropping the center. Eventually, I will, but I'm not worried about it for what we're doing. So I'm just going to make them all horizontal to make my life easier. Oh, I was also supposed to make them construction. Right, because these will clearly not be in these aren't part of the part, they're just there for playing with the geometry, right? So in our real one, we're pretty close to that height. We can look back and see what that looked like. Oh, maybe we can. What's it doing? So yeah, so our real one was a little like 4.5 tall. We probably don't need to be that full height if we're not covering anymore. So we could start potentially looking at making this get quite a bit smaller, since all it's doing is holding the drivetrain. I don't know if we could ever get down that small, but it's possible. You probably want to be a little bit bigger. Once you like flange it, you probably want the flanges to come out of it, because we're still going to have, so we're still going to have the 2x1 here connecting across. So we need at least 2 inches of face there. And we probably want to do, depending on how we got to figure out how we play with the belly pan and this flange down here. So this could get taller, but all of that can be done after the fact. I guess the real question is how big is this plate? Why is it a weird size? I don't know why it's not a rectangle. Jack can probably tell me why it's not a rectangle. Okay, so that plate is a little over 3. So if we wanted to keep that entire plate on there, we'd have to make it about 3 inches. If we weren't worried about it, we could make it less. But if once we're trying to put the dimple dies and stuff in there, I think it probably makes some sense to get closer to 3. Oh, and then what was it going to? And then so the other question is how far away from the floor is this bottom? Because that kind of sets your ground clearance. So before, in this past season, we had brought this up mostly because we just didn't need that extra weight that we would have had if we brought it down. The problem with that was, though, it ended up causing this part, like the Lexan guards and stuff, get really weird. Since we have to go up higher to mount them. But I don't know if we still don't know in our research if we need those, but not having this be a different part isn't all that useful if we're not covering the top anymore. So it's probably fine if we move this down and set some value. So if we know roughly from this center point to the floor, the center point of the wheel to the floor is about 3 inches in real life after it's compressed, because we measured that this year and got pretty close. That means we can kind of set the edge of this flange of the floor based on this distance, right? So whatever this is, 3 minus this gets us our ground clearance to the floor, which I think this year we set, what did we set that as? Oh, it won't let me until. So we set that at, you can count the Lexan thing. We were just under, we were about 1.5 basically, which is probably a pretty good ground clearance in a lot of years. There's reasons to go lower, but we don't need to worry too much about getting much off of that number. Because about 1 inch is about as low as we're going to go. Like just in general, if we're designing robots and we start, oops, that's the wrong way. This is 3 minus that number, so this should be 2. If we, no, that's still not what I wanted to do. This is supposed to be 1.5. I don't know why I'm bad at this, because I was just talking about something else. Okay, what? No, why are we doing weird things? All right, let me actually focus. It's way harder to CAD when I'm just like not talking about things I actually intend to. Okay, there we go. Now it's in the middle. Okay, so yeah, in any game, if we start trying to make our ground clearance really low, we should just immediately stop. We should take the lesson from 2017, not make a robot that is like scraping the carpet. It is not worth it, especially once you start doing like demos or anything else too. It gets way worse when you start like driving on uneven stuff. The advantage of having that slightly lower like belly pan and things is just not worth it most of the time. Especially when we're already running like 6-inch wheels, if we can continue to keep this drivetrain.
What would the advantage be of having the low clearance?
You can just start all your robot closer to the ground, so your CG gets lower, right? So like if your battery, instead of being 1.5 inches off the floor, is only a 1/2 inch off the floor, your center of gravity is lower, which is useful, but only to some extent, right? Like if you can do other things to keep everything kind of within your wheelbase, you're pretty okay no matter what. Like we shouldn't be designing robots that can tip over anyway. And with the pneumatic wheels, you're always going to be a little bit rocky. You're not going to be super solid no matter what you do, just because they have give and spring in them. But so far, the advantage has been really nice in that we can't be pushed sideways. So, or it's much harder to push us sideways since there's so much traction. Right. Okay. So things we know are there have to be some sort of, there have to be a 1/4 inch hole here for the wheel axle bolts. Oh, I haven't centered the wheels. Let me do that next. Okay, so those all get equal. We got to set our spacing for the wheels. So the way I do that is, that one is intentionally not drawn here because it's going to snap this midpoint, which gets kind of weird. And we don't want that. We want this line to be horizontal. We don't want it to be, we ideally don't want this to be snapped to this midpoint because it should be able to move. So if I change this dimension at all, it should move with it, which it does right now. Had I drawn it from here, it very likely would have tried to like keep this dead center, which is not what we want. And we'd have to go through and like either delete that relation or redraw the line. Neither of which is hard, but if we can think ahead and know it's going to do it, we can prevent it from doing that. Basically, I'm drawing these lines so we can get the dimensions between all the wheels, which we're actually going to set without having to set a new dimension because we know certain things. We don't need to. Oh yeah, see, it's already angry. Or did it get rid of it? Oh, it got rid of it for us. Okay. So it got rid of the midpoint dimension for us because it knew that was going to be annoying. Okay, so with all those lines, what does that look? Not construction. So we know we want this thing to be always in the middle. Because of that, we can go ahead and set these two to be equal since we know we want these two wheels to be the same distance away from it. And then we can also set these outside two to be equal since we know those should always be there. So now, even if I change this 30 number, the whole thing shifts whichever way we want it to, right? Maybe one year we're only doing a 28 drivetrain. It didn't attach at all. Okay, it deleted the relation entirely, which is bad. So I still want it coincident, I just don't want it midpoint. And I do want it horizontal. now it got angry. Okay, let's see. This is why we check things and figure out how to fix them. Okay, so this goes there. And now horizontal. Okay, now it's happier. We will need to eventually set one of these dimensions. So we do have to tell it how far away do we want our outer wheels from the edge of our chassis. So something like 3.5, whoop, I typed the wrong number. 3.5 is probably closer to right. It was like 3.47 in the drawing. We'll make it something easier to measure. Okay, so now, since everything is set up equal, if I change this, it should work, hopefully. There it goes. Okay, yeah, so it shrunk everything the way it was supposed to. And we could go through, depending on the game, right? This length might end up being like 31 something. It could be even tinier. You can't get too tiny if you're doing 6-wheel drive with 6-inch wheels. We can change something. It's not, we can make it a different number if we needed to. So one of the advantages of the potential use of dimple dies is right now the only way we have to be able to stiffen the middle of these plates is by putting standoffs across. But one of the things we ran into this year is there's just so many places where you can't put standoffs since you have these large wheels in the middle, and you clearly can't put a standoff through the wheel, right? Where here, if we only have this 1/4-inch bolt, in theory, we could dimple die a pretty good chunk next to these wheels and be fine, right? We're not using that space for much other anything else. We could figure out a hole pattern of some sort that let us put probably like a 2-inch die if we wanted to, some distance away from this point. Right, so you could do multiple of these, and now your whole inner structure gets lighter, but you're also adding stiffness where before you couldn't because you didn't have a way to put a standoff here at all. I'm gonna go ahead. We're probably gonna draw those later though, so I'm gonna not have that in there. And I'm gonna make this sheet metal now. I'm gonna make this actually the base flange. Okay. Let me see if I can go. I'm gonna go find the gauge table that we use. We can get the real 16th inch bend radius and everything. It is in GrabCAD. Wait, where is the bend table? Is it in? It's not in there. That's the other thing. Did I not pull it down on this robot? I don't think I pulled it down. That's a whole different problem. Okay, I may not be using the bend table because I don't think I have it on this work computer right now. I had it on this computer at some point. No, I do not. Okay, let's see if it can. Okay. All right, there's spectrum settings and there's the bend table. Okay, so it's in the spectrum settings folder, which is in GrabCAD, but I just hadn't had it downloaded on this computer that I'm on. Gauge table, select folder. And so then it'll let us pick the size of aluminum. So we're going to make this one thin. So it's going to be 0.06, which is a material we basically haven't done almost anything out of in the past. There are a bunch of teams who use 0.06 for their drivetrain. I think Hot has basically been doing it almost every year since forever. And so it sets everything for us. We get a, it's still the same bend radius though, as it was before. So we don't get that much of an advantage on the radius, but just having the thinner material gets everything a lot lighter though. So the basic stuff for what we do. So this outer bend always comes out this direction. It has to be relatively small. It's something like 3/8 or so, I believe is the smallest it's able to do. It's not set back from the right spot. And then we'll probably do, yeah, so it's doing full, it's doing bend inside. Probably want to do we want to do flange outside? For now, we'll do flange outside. So the top of this will be where it went. So we lose a little bit of our 1.5 ground clearance, but that's fine. We were kind of accounting for that already. And then is that really, yeah, so that's 3/8 to there. No, it should be outside virtual sharp. Okay. So that gives us 3/8 to the virtual sharp. Did we do smaller than that? We can go check in last year's CAD and see if we had them do it smaller than that or not. I think that's about where we were at. We can measure and see. So we had them do, no, it looks smaller than that. So they were able to bend 3/6 basically. So yeah, so pretty close to 3/8. I don't exactly know why we had them do it there. I have to look at why. I wonder if that may have been something they sent us, as if that's the smallest they could do. Oh, it's we gave them 1/4 inch to there. That's what we did. Okay, so we had them do 1/4 inch here, which is ideal, but not necessary. And they were able to do it last year. So to do that, we have to get this smaller, right? Since it's normal distance 312, it doesn't take off 312 minus 25 if we wanted to, which is how we get that random weird number. So we would subtract 312 minus 25 and get it tinier. But that should leave us at that 1/4 inch number. Yeah, so that normal distance. So now that flange is 1/4 inch. So now if we put a 1/4 inch piece here, anywhere along here, our bumpers, everything stays in like a nice inside the frame without having to do anything too weird. And they were able to bend this. It's definitely a small flange, but it worked and didn't cause us it didn't cause us too many issues at all. The top also has to stay relatively small because now it's not going over the wheels anymore. So we want it to be rather tiny as well. It's possible we could make those the same size, actually. We could go through and make this like a variable if we wanted or something so that they stay the same dimension forever, but it's very possible that we would change these flanges since they are doing different things. We may not want them to be the same size at some point. But for now, they're fine being the same size. Okay, so yeah, so that's kind of the general shape. And then we had to figure out, I'm going to turn on the visibility of this sketch so I can see the wheels again. And then we'd have to figure out, one of the things we could figure out is kind of where our hole patterns would be and how we would do the rest of the hole patterns. There's definitely a lot of details that would go into like, what does the end cap look like? Like how do we shape this? Do we change any of the, how the wheel is shown or anything? Do we make this an angle? A lot of that stuff can change. depending on the game and depending on what we need it to do. But for now, we can look at what the whole pattern would look like. So if we were, if we were going to assume that we have some type of symmetric hole pattern across the top and bottom here, let's see where we're at. So we can force that vertical. Force. Do we want to do? So yeah. So there's times where you have to figure out where you want a dimension from, right? So do we want a dimension from the flange up here? Do we want a dimension from this hole? Most likely, at some point, we're going to change. We're going to change the dimensions of this entire plate, very possibly, right? So what we could probably do is dimension from the top plate here. Actually, let me double check something real fast because I did not check it when I made this flange. Yeah, so we did material outside, which kind of hurts for dimensioning things. So that means our part that was 3 inches is measured off of like this face now, which isn't a problem. We just have to know that, so we can keep numbers kind of consistent. Because if we want to keep this symmetrical and have some reasonable hole pattern between here and the one below it, we need a dimension off of a number that's going to be that's going to stay the same. It's not going to stay the same. That's going to stay. That's going to stay an even fraction from the other side, right? We could dimension from the middle here, but then if we like grow the panel by 1/4 of an inch or by 1/2 inch or something, these holes are going to stay in the same spot. Which, depending on like how far in our development, that may be fine. But ideally, we probably want them somewhat outside at some point. The other thing we could do, or can consider doing, is do we want to use these same hole patterns as our standoff holes? If we were doing that, since we started using bigger standoffs for most things, we'd want to make sure we have like enough room to do that. So if we had a 7/8 standoff, which is what we started doing a lot this year on our drivetrain, this hole has to get further from that top edge. And we have to figure out if that's something we actually want. As this panel starts getting smaller, we may not want to do that as much, or we may want to change it to where we have some sort of like dual hole pattern where you have some holes that act as a 7/8 standoff, and then you come up in like a zigzag instead of doing a straight line. Most of the time we're not mounting. Most of the time we are mounting like another panel to this. We're not just putting a gusset or something pre-made. So there's no reason we couldn't have some type of a zigzag pattern that allows us to, on the bottom holes, have a bigger standoff, and on the top holes, either have a smaller standoff or just get our plate mounting without a single axis of fasteners. Does that make sense? So if you mount everything across a single line of fasteners, it's easier to bend across that line, where if you have like a zigzag pattern, that part of it is just going to stay more rigid. Since your fasteners don't have an axis running through them. So assuming we're doing that, we then figure out which way, we got to figure out which one do you want this to be. So if the center hole is our bottom one, what can we do? We can claim, do we want to claim that tangent? Not necessarily. Let's look. So I'm going to build up some sort of pattern here. These holes are going to be equal because they're the same size all the time. we're going to set some dimension from here and here. So like the vertical spacing on these holes. They're probably, so we have a choice of either like a 1/2 inch or a 1/4 inch. You could do something weirder if you wanted, right? There's some, you could do 3/8 or something odd. We probably don't want to. So if we drop to 1/4, we're probably fine there. And then one of the things we're trying to do is reduce some of the holes, especially if we're sending, I mean, even if we're routing it or if we're having Solarcraft laser it, we don't need nearly as many holes as we had been using. We can get by with less. So if this zigzag pattern is on 1 inch, we're probably fine. So now we know a few things, and we still got to figure out where we can come back to here. I believe, let me double check this dimension to its same line down here. Ooh, where is that line down here? That line down here doesn't exist. Oh no, it just won't let me do it. Okay, let me measure instead. So there to there, yeah. So that's those are our 3-inch lines. So that gap is one of the things that we have set. So we've set the distance between our flanges to be 3 inches. It's very likely that could change, but ideally if we keep that on some sort of 1/2 inch pattern, if we jump that to 3.5, if we keep this dimensioned off of that, the hole spacing here and here will all come out to be reasonable. It won't be some awkward number that we don't know or anything. So in that case, we want this number and this number to be a real thing. So this is a place where we could start looking at doing something like 3/8 probably. It's not going to give us a perfect number down here. We can see what it looks like when we flip it. Let's see. Can I mirror about you? I can't. I need an actual entity in there. Okay. So I'm going to convert this to be in this sketch. Make sure it's for construction still. And so I can mirror about that line. Oh, no, it's telling me to incorrect. So I want to mirror about that line. There it goes. And then I want to mirror this one and that one. Okay, and we can see what that distance is right now. And that can help us set how we want to play with these holes in the future. Because we may have to mount all the way across them, and we don't want them to be too weird of a hole spacing. Yeah, so right now they're 2 1/4 and 1/75, so it's not terrible. If we could move this to 2.5, that would get them 2 and 2.5, which is probably nicer, but now we start running into bigger problems. So like this hole gets really close to that flange. That line right there is the start of the bend. We probably don't want to do that. A 7/8 spacer doesn't fit there. So we're probably not doing that one. If we go up to 5, we get 1.5 and 2, and those are definitely nicer numbers, but now our standoffs are like much closer to our center axis, which may not be a problem. This number, however, gets like much farther away here. So one of the things we can do is, now that we know this hole spacing, if we want to say, okay, the 3/8 number is actually cleaner for all the holes, how do we change this spacing? Because we haven't made this plate yet, right? There's a lot of things that we can set. We could go back and change the overall width here to clean this number up and give us a something on the 1/2 inch spaced. So if we go and make that a 3¼ inch panel instead of a 3-inch panel, it's going to change that number in a cleaner way. Maybe. Okay, so we made it 3¼ We didn't change, because of the way we dimensioned it, it didn't change any of our ground clearance, which is ideal. Like there's no reason that the wheels need to be in the center of this panel at all. It added a little bit of height, but that's probably fine for what we're doing. So if we go back into that sketch, why did it not do what I wanted it to? Oh, it didn't like update. Oh no, because it still mirrored about this center line and not the center line of the panel. Okay, that makes sense. That's one of the things that you run into, right? So I was using this line as the center line of the sheet, and that wasn't true, right? That was the center line of these wheels, but that can move. So that's one of the things you have to watch out for a lot when we're designing stuff, is actually using the relation that you want. So I'm going to delete those 2 circles. And I'm going to get a new center line, which there's multiple ways to do it and make it for construction. And so I could come over here and pull the midpoint of this plate, which is one way to do it. The only issue here is if I were to ever go back in and change, like if we know one of the things we could do potentially is like change the side profile here, if in case this isn't flat one year, or whenever, if just later on we decide we don't want this flat, this may get awkward. That may not be midpoint. So instead, so I know where we want the midpoint, I'm going to draw the line here. I'm going to get us a new line between our 2, between our 3¼ lines. So that's the, so we know what this is set at, or should, that didn't work. So we know what this is set at, or we should, so this should be 325. It's going to tell me it's already dimensioned. You know. And then we're going to pull the midpoint from here and use this as our, we'll use this as our mirror axis. All right, so I can mirror, what am I mirroring? I'm mirroring these 2 circles again, Control click, and then I have the center axis. Okay, so now when we check their dimensions, so this won't let us dimension it, right? We already know what the dimensions are. It's going to be mad at us, but some reason it, so yeah, so that got off, right? We were expecting that to be 2, and it wasn't. So now we need to figure out why. Why is a good question. No? I do something weird? Why is that not? Oh, seriously, why is that not 2 inches? Does anyone know what I did?
Oh, because if you move the line, then doesn't it also, because you move the top one closer to the line? I mean, if you change, maybe, or if you changed the, where it was being mirrored from, if you moved it up, it's closer. Oh, no, wait, but then wouldn't it be less? All right, never mind. I'm not sure.
Now I'm trying to figure out what I did. I definitely messed up somewhere. I'm just not sure where. This line can't move. This line's in the center of this line. This line is 3.25 inches. What did I do? Well, that's weird. Hold on.
Wait, I mean, doesn't it change the, because you're mirroring it from a different line. So, from the wheel to the center line, it would be less. Or just
Did I click
Or-
the wrong mirror line? No, I'm not, but I'm not measuring off the wheel, right? I'm measuring the distance between these two holes. Did I mirror the wrong, did I click the wrong line when I mirrored? Because now I'm confused. I was going well. It's always weird CADing when presenting, because I'm like trying to think ahead, but then when it messes up, I get, it's trickier to come back on. Okay, what did I do? So that circle, that line, that makes sense. Yet for some reason, if we measure that, it's not 2, it's 2.039. Okay, hold on. So this is easy enough. So that means there's a problem between here and here not being 1. It's 10195. So then what is this to this? Some strange number? What?
Oh, because that's half of 3.25.
No, it's not. Is it? No, it's close to half of 3.25, but it's not half of 3.25, right? Yeah, like that doubled is not 325. It can't be, because 4, 5 makes a 9, right? But why? Oh, because this is moving. Okay, there's our problem. We have found our problem. This didn't get midpointed. It just looked like it was midpointed, but it was not.
Oh,
Even when I had the relation and it didn't actually draw the relation. Now it's 2 inches. Okay, that makes way more sense. It wouldn't let me move the line, yet it was not actually fixed. Whenever, so sketching on a part gets weird because it's harder to tell what like the color of things are all the time, like whether it's blue or black. So if this wasn't actually fixed, it would be off. I was like, I'm pretty sure my math says this should be 2, and it just was refusing to do it. Okay, so that's happier. So with that, what can we do? So these are basically the start of a potential hole pattern running down the whole length of it. So we would, so you could either do this as you can either do it as a feature pattern or a sketch pattern. Either of them work. Most of the time I do them as sketch patterns, but I know a lot of people who hate sketch patterns and do them all as feature patterns. It doesn't really matter as long as it gets the job done and you know how to edit it in the future. So we're going to look at bringing these two over. So these are going to be on a deeper sketch pattern since each of these are already 1 inch apart, right? This specific hole, we want double that, right? We want it 2 inches apart for the next actual pattern. So in this column up here where it says like the distance apart, we do 2, and that'll get our kind of zigzag pattern moving along. And then we hopefully figure out how many of them we need before we touch the edge, which we know this whole thing right now is like 30. So there's like 15 inches or so. So it's going to be 6 or 7. Oh, maybe 8, but 8 might be too much. Yeah, 8 gets weird, but that's probably fine. So we can go into instances of skip if we want and tell it not to make that one, although it gets weird sometimes. Oh, no, you can't because because we did them both at the same time. It won't let us just skip one part of it. So we have some options. We can either go back and only do each hole and have them each have their own pattern. We could also assume that we can draw in whatever we want in this corner ourselves, since this corner is kind of going to be weird because there's a wheel here anyway. We could, in theory, put a different hole pattern here. We could do whatever we wanted. So for now, I'm going to leave that blank, and we can go back in and fix it if we need to, and just leave it at 7. And for what we're doing, I'm actually going to do this one and this one at the same time, since we've already mirrored them and we have those ready to go. And that'll let us kind of just start playing over in this area, and we can see what other things look like. So what was my thought? So my thought is now we've kind of built up, you kind of start seeing where we have this space in the middle of these holes, right? And so that space starts looking like a space where we could potentially put our cutout circles. So we could figure out how big they are. I don't know if that, yeah, so at some point they get too big probably. And if we're 3D printing the die, we can make whatever size we want. In theory, we can probably buy most sizes. We've looked into it. I've looked into it a little bit. They make a lot of them. It's tricky to find a 1 1/8. I was trying to figure out if you could do it in like the bearing hole size. They do exist. They're just relatively tricky to find. Ooh, that started moving stuff. Let me not do that. That got weird. I forgot to check some buttons. So I'm gonna go back in and edit that pattern. So we do edit pattern and keep that at 2 and make sure I do dimension X spacing so that it forces those to stay, because it tried to move those and that's what's good. We do not want those to be able to move around. Okay, so now this can move a little bit, but we'll tell it to stop moving by telling it to be on this midline. Okay, so that can't move anymore. So a 2-inch hole is pretty aggressive. We start getting towards these mounting holes, right? That may not be a problem, but if we start looking at what a standoff looks like here is where we probably want to avoid it, because we almost certainly don't have room for a 7/8 standoff there. Yeah, so we start hitting there. So in this size plate, if we started moving it down a little bit, even that gets a really thin web. And if we're assuming we're flanging this out, this hole's going to get bigger as you flange it out. So something like 1.5 inches is probably closer to what we want. So that lets us mount this flange out. This is not cut out at all, right? This is only where the standoff goes, but it gives us more enough room for that. Like we might be able to get by with that 1.75, but it's probably not worth it. Make sure that's construction so it doesn't get weird. So we could see we could do these a lot. We could figure out, does it make sense to do another one, or does it make sense to pattern one? If we're patterning this, we know it's going to be what, it's every 3 inches. Oop, that's not what I wanted. I wanted to put it. Nope, every 2 inches. So yeah, so you could do a pretty aggressive hole pattern going all the way across them if you wanted. This doesn't leave room for like any sort of standoffs across the middle though. Right, so we'd only have standoffs this far in and we wouldn't have anything in the middle. So it might be good to skip an instance, depending on how we wanted to do it. Like here, we probably are skipping one because of the wheel anyway. Like we have a wheel bolt, we may have to like reinforce or something. We probably don't want a giant cutout right there. So because of that, we probably are skipping one. So it means we're probably on like 4 inches. And so that one gets odd too, because now this is, this one's over a wheel, or this one's in a wheel, which you don't want. There's also reasons why these ones don't also have to be on the pattern, right? We could in theory put them wherever we wanted. We could put one here. We could like sneak one in. We could get rid of some other things. Like none of it has to stay on the pattern. It's kind of what we're looking at for our initial version of this. I'm gonna go ahead and make that 2 instances and get rid of that other one for now. We're also missing a portion where somewhere in here we have to put in we have to mount a gearbox to this plate at some point, which is going to change quite a bit of this anyway. Okay, so what I'm going to do now, though, is I'm going to go ahead and put a center line down from the center hole. We know that that wheel is going to stay centered basically forever, so we can use that as a feature hole or to use that as a reference. So I'm going to mirror everything past that. So we can put it on the other side. There it goes. I missed entity. Oh, what's happening? Missed that one, and I missed that one. Okay. So that gets us close-ish. You start getting way too many relations, so we can turn off relations, hide show, sketch relations, to get less green. And then we can tell all of that to go to up to next, and it'll cut through the panel. Yeah, so now we have this thing that is close-ish to some form of drivetrain. I haven't actually looked at how to put the Dimple Dies into CAD yet. I have not done that. I know at some point I played with this back when I was doing at my actual job at one point, but not in a while. So you use forming tools. It does the inverted dent thing. But you have to get the you can get different tools and stuff that you can do it with that we can pull from. So it's definitely a way to do it. I don't think there's another version that does it well. I don't think you can do it on a round hole, can you? I think it gets mad. I think it says no, which would make sense. Yeah, so I think you have to use a forming tool to go through and actually press in this, which is something I'm going to figure out at some point. That's basically just going on YouTube and figuring out how to do it because I've never had to do it before because it's not a tool that we've used. Okay. Does anyone have any questions so far on what I was like playing with or what I was doing? We're sitting at about the time where the meeting can end. I'm probably going to play in CAD for a while, so I'll leave it on the stream. But does anyone have any?
I have a question.
Yeah, what's up?
About something you said earlier about the top of the drivetrain not being there.
Yeah.
What's happening?
What do you mean?
Like you said something about the top of the drivetrain, and I didn't fully catch that.
Oh, my point was that as our drivetrain develops, we've in different years we've had a top and we haven't had a top. We basically didn't use this year, right? Pretty much the only real thing that mounts to this is this gusset, and this gusset isn't even the best way to really tie in the elevator support anyway. We had the other thing that mounted there was we ended up putting the square bar there, but that was kind of janky to begin with, right? Like the original plan was not to mount it the way we did. The original plan was to have it be a cross member, but we had to get it out of the way of other stuff. So largely we don't really mount much to this top surface. So it doesn't really do anything, right? It's just extra weight. It stiffens things up because you do get that box there, But you can do that in other ways, right? Like
Which
having
one with the
standoff
dimples?
is fine. What
What we're doing with dimples?
the dimples help stiffen the sheet, and having standoffs help stiffen the sheet, and it gets it lighter. You also remove the potential for the ball to be stuck between the tire. You can also get to the top of the chain and stuff. Right now, to get to the drivetrain, it has to be on its back. If this is gone, you can actually get to the rest of the drivetrain from the top, which is convenient at times.
Okay, yeah, that makes sense. It's just plates, and then there's stuff. Nice.
Yeah, because we've had, again, our 17 drivetrain didn't have a top. Our 16 drivetrain had partial top, right? The front and back pieces covered up parts of it. And then, then we added, the 18 was the weird closed box thing. And then 19 and 20 is when we fully closed it. And we had some reasons to do so, but it just starts taking up space that we just don't really need it to, right? There's a lot of empty room inside there for no real reason. It keeps it a little bit cleaner because the chain and gears don't throw grease, but our grease is now not dirty anymore because we use all the clear PTFE stuff anyway. So it's largely cleaner. So things that do get a little bit weird. So since we have that forming tool, you do end up having to space off. The tire can't be, or the wheels can't be super close to the wall. They normally haven't been in the past anyway. But we do have to worry about especially if we keep the pneumatic tire, you have to be worried about the tire valve hitting. If this is pushed in, you'd have to worry about the tire valve hitting in the flange part that's pushed in there. So that's something we have to consider. Same with making sure anything else that's rotating doesn't hit it, chain, anything like that. Most of the time the chain isn't going to, but maybe on the other side, if we had the same panel or some version of this panel on the other opposite side, you wouldn't want to have, you got to make sure nothing hits those dimples if we're adding those in.
Is there still a flange on the side?
This side over here? Yes, the box end I just haven't played with yet because there's multiple versions of how to do this, right? So there's at least a flange coming in. But here you could, depending on if we ever if we wanted to cut this back for ground clearance issues, which we probably don't do with the way our chassis is currently made, just because of the 2x1 that has to cross it anyway. We don't. There's not a nice way to do the wheel cutout version. So these are probably bent, and then it's a matter of, okay, do we how are they bent? What's the plate look like? Do we just do a flange here big enough to let us mount to it? Because one of the things we do have a problem with, right? We don't have a lot of room. We can see where the wheel is. And with the pneumatic tire, this could get slightly larger too. You don't have a lot of room for standoffs or anything. So if that's the case, do you make this flange big enough that you could actually put holes in? And if you do, is it big enough? How do we do that, right? So there's some, right now in theory, because of how this works, we don't really care about the distance on this flange. So if we could bend this on our own sheet metal brake, that was wrong. That did not get pushed to outside. That has to be bend outside for what we're doing at the moment. That could change later in a second, but for now, that way. So we could bend this on our own brake, since there's no mounting here. As long as this is kind of close, we don't actually care how this bend works, right? This bend doesn't, there's nothing that mounts to this. If this is not perfectly straight, that would be fine. It gets weirder on the inside panel if we mount a belly pan to it. So that's one of the things we have to consider is if we bent this ourselves and we made this longer for the inside one, so we could put rivet holes in it, do we do we figure out a way to do some of it in-house, or do we just wait on Solarcraft to do them all? And even with Solarcraft, we still have to make sure they get the bends right too. Like they're not always completely perfect. So it gets weird when we start doing the stack up. Like the one on this year's robot was a little awkward. Mostly our fault because we sent a drawing that had a weird dimension. But getting like that sandwich is definitely tricky to do exactly right. Because you have so much, you have the tolerance of the bend, you have the tolerance of the wood, which is pretty close to 6 millimeters, but it's not always exact. And then you also have the tolerance of the 2x1, which is pretty close to 2 inches, but isn't always exact. So you're trying to get all of those matched up. And one of the nice things is you can just change the 3D printed part if we want, because right now the way we do it is we have a 3D printed part on the inside in here, which we'll go over on Thursday a little bit more for people who have not seen the drivetrain as much. But there's that 3D printed block right here that sets where the threaded rods are that go all the way through this beam and compress the whole sides together. So yeah, so we can figure out how to do this inside flange potentially differently, whether we do it with holes already, or maybe you do the flange without holes, and this laser cut panel that's wood, we clamp everything up and then just drill through and rivet, because we don't actually need these to be in relation to anything, right? I'm trying to think we've ever come back in and mounted a CNC part to these hole spacings on this bottom flange that wasn't just the belly pan. I don't think we ever have. Since we know we only need to mount the belly pan to here, in theory we could do this without holes and then just match drill all the belly pan holes too. So even if we get this bend slightly off and the holes don't, right, we don't have to worry about hole alignment. We just do it after the fact, which is the same way that Hot has been doing their sheet metal drivetrains for a very long time. Yes. Okay. So what else do we want to play with? So steps to getting this further along. So I would put this into an assembly with the actual wheels, some version of a gearbox, probably the same one that we ran this year. There's some issues. One of the things about this year's gearbox that is kind of annoying is that we had to have this big of a chain reduction. So again, we'll re-go over this on Thursday, but this was 32 and 12. I think that's 12. Yeah, so it's 12 to 32 coming off, and because of that, the sprockets dip below the bottom of our the clearance. They like dip below our ground clearance number, which only has to happen, which happens at these front two because of the way we geared them. This back transfer is closer to not happening. I think it actually doesn't happen because of the 22 tooth sprocket. Yeah, so it goes straight across. So that's a little bit nicer. So if we could eventually do them on, if we could eventually have this final reduction be 22, that would be easier. But there's no good way to do that in our 1.5 stage reduction gearbox thing that we discussed a few weeks ago. Because you just can't get more reduction out of this. So that leads to issues where basically somewhere we at least need a 32. And there's some games where you might even want to be slower than that, and that's much harder to do, right? Because that sprocket has to get a lot bigger. because the only other way to do that would be to make this sprocket smaller, which isn't really an option, or to have some sort of other gear stage somewhere in here before going into one of the wheels. This would have been less bad if we had just been able to put the gearbox somewhere else, right? Had we been able to move the gearbox closer to one side and chain differently, I think there's definitely ways we could have gotten a little bit cleaner than what we did. Yeah, that definitely was never. That was never not a perfect solution in what we did, but there's different things we could do, right? In theory, we could even we could add some gear reduction back here with another stage somewhere, which I don't love. There might be a way to do that. Actually, so it gets a little interesting. So, because we only have to, so we only have to get a reduction into this gear. There's probably a way to do that in the same, what am I trying to think of? There's probably a way to do that in the same, without moving the motors backwards. Like the whole gearbox would get longer, but largely that's okay. Right? It's not like we weren't using this space for anything, right? Like there's nothing going on up here. So if the gearbox got a little bit longer, it doesn't really hurt us. That's something I would have to look at. Oh, but you'd almost need to have like the motor stacked to do that nicely. That gets weird. Because then that does get it taller this way, which we were trying to avoid. There is one thing we could do to help our gear reduction, which is right now these are 10-tooth pinions. We could, it's very likely we're running Falcons on our drivetrain for the foreseeable future. And if that's true, we could run 8-tooth pinions. So we could get all the way down to 8, which gets us a lot slower since instead of being 10 to whatever this gear is, oh, it's in 60 tooth. So this is like 10 to 60. We could go 8 to 60, which would get our whole thing slower. So there's some version of